Hello everyone. I just wanted to post a couple videos going over the part 2 review sheet. So question number 1, we're talking about SAT scores, and we are given the stats from the calculator output. So in part A, we are asked to label or find certain values. The values that we're going to find are the mean, which is given right in the output. That is my X bar value, and that is 531. Then the next one is the median. That's also quartile 2. I'm not going to label it like that because for the output it's not, it's median. And that actually is 533. Then we need to calculate the range. Remember what the range is. The range is just equal to the max data value minus the min data value. And we're given those at the bottom. The max is 800 and the min is 341. So that gives us a range of 459. Next, we want the standard deviation. This is where I get most of the questions on this problem. Well, I shouldn't say on this part of the problem, because in here for the output that's on the sheet, you're given SX, which is 38, or sigma X, which is 37.8, and we need to know which one to use. Remember, sigma is population standard deviation, and S is sample standard deviation. In the problem, it tells us we're studying the scores of a sample of local high school students. So right there, you know you're using S. So I'm going to just write that here, SX, so we know which one we're using. And that's why. Most of the time we do that, right? I tell you that all the time. Most of the time we're going to use the sample because that's what we're studying. Okay, and then we have the IQR we're looking for. Remember what IQR is? This is just quartile 3 minus quartile 1. Quartile 3 is 555 and quartile 1 is 505, which gives me a difference of 50. So the width of my box, if I was looking at a box plot, would be 50. That's what we're looking at. Okay, so that's the first part of A. So it's 1. And the second part of A just needs a simple explanation of why the empirical rule can be applied. The empirical rule can be applied because this data set is bell-shaped. So I'm just going to say, since the data is bell-shaped or symmetric, either one of those means the same thing. And the reason why we know that it's bell-shaped or symmetric is because the mean, X bar, is almost the same as the median, right? The mean is 531, and that is almost the same as the median of 533. They're fairly close. When we have a symmetric data set, the mean and median are almost the same. Remember, this is stats, so we could say they're the same if they're just similar. They're close to one another. Okay, that's how we know it's symmetric. Remember, we can use mean and median to tell the shape of a data set. So if the mean is less than, it's skewed left. If it's less than the median. If it's greater than the median, it's skewed right. Okay, so let's move on to part B. Part B asks you to draw the empirical rule. I will not ask you to draw anything for me on this exam. I may ask you to draw it on your own and use your own drawing to answer questions for me, but I will not ask to see a drawing. The other thing I may do is I may ask you to fill in the blanks. I may give you something like a curve, and I might have blanks here to fill in, and I might want you to fill those blanks in. So just keep that in mind. That may pop up. So right down the middle of my empirical rule, we use our X bar. I'm going to fill these data values in shortly. Then remember, the empirical rule goes by standard deviations. So this is X bar plus 1 times S. Then the next one is X bar plus 2 times S. And then the third one is X bar plus 3 times S. And then it's a mirror image on the left side. It's just subtraction. X bar minus S, X bar minus 2S, and X bar minus 3S. So I can do this calculation. So my center X bar is 531. We already picked that out above. All the information we need is above. We need the standard deviation. We already said that was 38. in part A. So when I add 38 to 531, I get 569. Okay. When I add 531 plus 2 times the standard deviation of 38, I get 607. And then for the last one, for 3 standard deviations above, I get 645. And now I'm going to do the same thing for subtraction on the left side. Okay, so there's my values. These are my data values. Now I want to fill in here with some percentages on my empirical rule. So I have a couple different ways I can go. I'm going to do it both ways right now. So remember the empirical rule, I have these overall center or these middle percentages. So within 1 standard deviation, I have 68% of my data. Within 2, I have 95%. And then within 3, I have the 99.7% of my data here. Now I'm going to fill it in individually. This is what's really actually more useful. Not that that's not useful. This is very useful. I'm going to fill in each section because if I have to do a percentile later on, I have to add the percentages up. Or if I'm just looking at something with the percentages, I need to add them up. So I'm going to do that. So over here in this tail, it's 0.15%. And then I have 2.35%, 13.5, 34 for the 2 middles, right? 34 and 34 give me my 68. That's where that comes from. 13.5, 2.35, and again, 0.15. So remember, it's a mirror image. If you folded your paper on the mean, it'll be the same on both sides. Okay, so this is my drawing. Again, I might ask you to fill in blanks or just have this on your own. You won't need to show it to me if I ask you to draw any graphs like that in the exam. I won't ask you to draw anything and show me. I just may ask you to label something like that or just use it. Okay, so let's move on. Part C. So it says approximately 68% of students scored between these 2 math SAT scores. So approximately 68%. So right here, 68% should jump out to you because I have the 68 right here in the middle. So that means that between 493 on the SAT and 569, I have 68% of my students scored between those 2 values for Part C. Part D says that only 2.5% score above this value on the SAT. Above means to the right. It means it's greater than the mean, right? So I'm looking up here and it's 2.5%. So what I'm going to start adding from right to left. 0.15 plus 2.35 gives me 2.5%, right? So then I'm going to look at this data value here. 607. I don't add the data values. It's just 607. So what this says is that 2.5% of the students scored above a 607 on the SAT. All right, and then E, this is the one I have the most questions on for this problem, and this is a percentile. We have to remember what percentiles mean. I'm looking for the 84th percentile. Percentiles break my data set into 2 parts, a lower part and an upper part. So when I'm looking at the 84th percentile, it means that I have 84% of my data values are less than my 84th percentile, which is a data value. Or I can view it on the other side where I could say, well, 16% is greater than, right? Because the 2 percentages add up to 100. So since I'm looking for 84th percentile and I know 84% is going to be to the left, I'm going to start at the left and work my way to the right and add up. So 0.15 plus 2.35 plus 13.5 plus 34 plus another 34 gives me 68. Or I'm sorry, 84. I looked up and saw 68, gives me 84%. 84% to the left of this data value right here, 569. So 569 represents the 84th percentile. That means that 84% of the students scored less than that data value, the 569, and 16% scored higher than the 569 on the math portion of the SAT for this sample. I hope that helps, and I will talk to you guys soon and see you in the exam.